All right, I'm going to run through a quick example on how to use Fusion 360's CAM utility to generate G-code for the CNC Nebula router. But first, I'm going to create a part for us to generate this G-code for. So let's go ahead and just create a new component and create a sketch in the XY plane. And let's just create a few features for us to machine. Let's make this guy 0.75 inches. Let's make this 0.125 inches. Let's make this 0.165 inches. All right. So I'll resize some of this stuff, just to make it a little bit cleaner. And why don't we go ahead and put some fillets on that box. All right. So now we have a sketch. We need to extrude it. Just hit E for extrude, and I'm going to extrude it in the positive Z direction, 1/8 of an inch. So this tutorial is strictly going to be for 1/8 inch aluminum using an 1/8 inch two-fluted end mill. We found that this is probably the best combination for some of the stuff that we do. So, all right, so we have the part. Let's go ahead and go down to the CAM tab. So as you see here, we're in the CAM tab up here, listed here, and essentially what you want to do is you want to work left to right across this. But what I've done is I've created a profile, and this should be pretty straightforward. But first, you need to go to Setup, create new setup, and so we're doing a milling operation. I'm looking at the model orientation here, and it looks good for the Nebula CNC router. The short side of the table is in the X direction, the long side of the table is in the Y direction, and then the Z is in the positive Z direction, I guess, from the table. So a rule of thumb that I like to use is just always keeping the working coordinate system on the bottom left side of the stock part. You could really put it anywhere, but this is I guess what we've been using. So I'm going to go ahead and select the box point for our working coordinate system in this bottom left hand corner. And now what you can see here is that our stock, this yellow material, is too big. Our actual stock is an 1/8 of an inch thick. So what we have to do is go into this stock tab here and change this to fixed size box, and you can see it made a little change. But if we go down here into the Z height, we can change this to 1/8 of an inch, and you can see it is now the thickness of the part. The other thing that I like to do is to make the stock a little bit bigger, much bigger actually than the part. One, this makes sure that you have plenty of space to clamp down the part, and to do that, let's just go ahead and make this 5 inches and this 4 inches. Okay, so now what we have defined is the stock orientation, the stock size, and the part reference to this working coordinate system. All right, so we're going to click OK. And so now our setup is complete. So what I've done is I have created templates or profiles for different types of stock and mills. Right now, what we're going to do is we're going to download a template. So create from template, go to select template, and then navigate to wherever you have downloaded this profile. This is for 6061 aluminum, 1/8 inch thick, with a 1/8 inch carbide end mill. So we're going to go ahead and click this and open it. So you can see right away that there is an arrow here. So if we were to expand this, you see now that we have a bore operation, a drill operation, a pocket operation, and a contour. So I'm going to just go through here and walk you through how to apply these operations to the features on the part. All right, so let's go ahead and, so you right click on the operation, you edit, and the way that this is set up, you don't have to change any of these feeds and speeds or any of these different knobs and things like that. So just go to the geometry, and all you have to do is select the operation that you want to bore. And since this feature here is 1/8 of an inch, we're not going to use that one. We're going to use this one that's a little bit bigger. And as you can see, all I have to do is select the face and click OK. And then for the deep drilling, just right click, edit, go into the geometry tab, and just go ahead and click the feature and click OK. And for the pocket, just right click, edit, go to geometry, and what you want to do for pockets and for contours is you want to click the contour that's on the bottom of the stock. It's a little quirk that's in Fusion 360, and since we know that the bottom of the stock is here, let's just go ahead and click that contour there, and now that is going to do a pocket. All right, so something that we should probably address here, if you're not familiar with machining, is what is the difference between a bore, a deep drill, and a pocket. So if you want, we can go here into the operation and we can simulate it. And what I found in Fusion 360, the defaults are a little bit weird, so just come in here, change this to flute, show the tool path, make sure that the stock is selected, and then I use the wall paint. It gives a nice contrast. So if you press play down here, it'll simulate this singular operation. And as you can see here, we have an 1/8 inch end mill, and it is almost in a helical pattern, creating this feature that is bigger than the OD of the mill. And so that's essentially what a bore is. We traditionally use bores. It gives a better tool life than the deep drilling. And the other thing that we like to do is for rivets, even if we have 1/8 inch rivets, we'll make them a little bit bigger, so like maybe 0.15, and that is perfect for this bore operation. For the deep drill, it's essentially Peck drilling, and what Peck drilling does is it plunges into the material and retracts, and what that does is it allows the chip or the pieces of the metal that it's machining to come out of the well. And so if we were to go to simulate this, I'll zoom in here, you'll see that it will go through a Peck drilling cycle. All right, and then for pockets. So the way that I have configured the pocket is it's going to do an adaptive clearing of the feature in 2 passes, and then it's going to leave a small amount of material along the edge that is then going to be on a finish pass. So if we were to simulate this, and you can see here that it's leaving a bit of material to grab on its last finishing pass. Now, this operation is great for bearings or things that are press fit, things that need tight tolerances. The next operation that we're going to show you is the contour, and for contours to work, you usually have to leave a tab. And if, for reference, this was a bearing hole, the tab would leave kind of an imperfection when you go to cut it out. All right, so the last operation is the contour, and this one is a little tricky, but all you do is, again, you go in and you click Edit, and you have to choose the geometry that you want to contour. So I have this set up to, I guess, machine the inside and the outside of parts. You can go in and change that if it just really depends on what material you're trying to save. So this looks good here. The only problem is that when this goes to machine, once the contour is finished, this part is going to be floating, and there's a chance that it will crash into the mill. So what we have to do is we have to add tabs. So if you see here, there's this tab, I guess, drop-down menu, and you want to click here on the tab positions. And again, what you want to do is click the bottom of the contours. And for aluminum, I found that these size tabs are one tab per feature is usually pretty good on the interior, and then on the exterior, I will usually caddy corner 2 tabs. All right, so that should be it. We click OK, and we can simulate this feature. Now, what this is going to do is it's going to create a contour in 2 passes at about 60 thou deep. So let's go ahead and start the simulation. You can see here that it's going to do 2 passes. I think you get the idea. I'll speed it up a bit. All right. So one thing that I like to do before I go ahead and generate the G-code is that you can simulate this entire process. So just right click up here on the setup and go to simulate, and you can see it has all the different options. What I've done is I've put the contour at the very last operation so that these other features don't, well, so effectively when the contour is done, the part is less rigid. So if you do these other operations first, they won't flex the material and cause you to miss out on any tolerances. So I'm going to just go ahead and just show you real quick how to simulate the entire process. Click play. And it's good to watch this just to make sure that you didn't make any mistakes or that you didn't forget any features. I'll just go ahead and speed this up. All right. So the last thing that we need to do is to generate the G-code. So, let me mention something real quick. So say, for instance, you don't have a bore operation on your part. All you have to do is right click and delete this or suppress it, or I guess I would just delete it if you didn't have this feature. But these are really the 5 different operations that we primarily use for machining. So if you don't have a part feature that has one of these operations, you can just go ahead and delete it. All right, so U is post-process. Okay, so essentially what this is going to do is generate the G-code like I mentioned. You have to come down here and select Linux CNC. That is the controller that the Nebula CNC uses. And then you have to define where you want your G-code to be saved. Right now our Nebula CNC router is not networked, so what we usually do is we ferry a USB back and forth between the computer that we generate CAD with. So just navigate to that wherever you want it saved. Sure, we'll save it here. And then this is where you can put your program name or number. it's not really too important, and then you click post. And then this is where you can now save this. So we can say this is tutorial and click save. And if you don't have brackets installed, Fusion 360 will install it, and then a window pops up with the G code. This is sometimes good to look at to check and see if there's any issues, but primarily this is the entire workflow for generating cam. All right, that's it. I'll be creating another tutorial on how to actually